So can you see that okay? I can put it on a bigger screen for you, or a bigger diagram. So third root of 216. So this chapter, this is section review number 5. It's our last review. This again is more topics from intermediate algebra. So okay. So how do you simplify roots? Well, basically that little number in the hook tells you that it's a 3-for-1 deal. You're going to ship out 3 for 1. So we gotta break down the 216 first off with our calculator. So I don't know 216 either as I look at it. Just take the 216, divide by 2, for example, and it'd be 108. And then divide by 2 again, 54. Now there's something I recognize. 6 times 9. And just keep going. I'm not done yet. The 6 can break down, right? What times what is 6? 3 times 2. And what times what is 9? 3 times 3, right? So can I break down any more? No, that's as far as it's going to go. So I took that 216 and I broke it down as far as it would go. Down to primes. I just kept breaking it down. Okay, so that means the 216 is the third root of 1, 2, 3 2's and 1, 2, 3 3's. Now you might wonder, well, why didn't you write down the 6? You know, why didn't I write down the 6 or the 9 or the 54 or the 108? Well, because they broke down. Right? I only wrote down the primes, the numbers that couldn't break down anymore. I just broke it all down to the little bitty building blocks that make a 216. You can check it on your calculator. If you did 2 times 2 times 2 times 3 times 3 times 3, that'd be 216. Those are the little pieces, the little DNA that make a 216. So we break apart the number down to its primes. And then, look over here at this 3. What is that 3 telling us to do? It's a 3-for-1 ship out. Meaning, it's like you go shopping at Target, things are on sale 3 for 1. So you say, okay, 3 2's in the store are on sale, 3 for 1. So when you go out of the store, you pay for 1 2, don't you? And they're gone. Same thing with the 3's. They're on sale 3 for 1. That's what this 3 here is telling you. He's the director. Whatever's in the hook, that's the number telling you it's a 3 for 1 deal. So 3 3's in, ships 1 3 out.
So there was 4 4, it would be that way too.
Yep.
Okay.
Anything there's 3 of.
Okay, 3.
So what comes out then? A single 2 and a single 3. And what do they do on the outside? Exactly what they were doing on the inside. What were they doing on the inside? Adding or multiplying? Multiplying. So they multiply on the outside. 2 times 3 is 6. What's left inside the root? Nothing. So the root vanishes and the answer is 6. So the 3 in the hook is a 3 for 1 deal. Questions, it's kind of funny the way I wrote them. But yeah, you're exactly right. That's 2 times 3. All right, let's try number 2. So number 2. Cube root of negative 64. So same kind of thing. We're going to break down that negative 64. So take, oh, by the way, the minus sign, that's just going to pop to the front. Don't worry about the minus sign. Just take the 64, take your calculator, break it all the way down. It doesn't matter how you start. Just start breaking it down with your calculator. Find all the little pieces and then do a 3 for 1 ship out. Okay, so let's break it down. Like 8 times 8 or 2 times 32 or 4 times 16, however you want to go. Doesn't matter. But then you got to keep going, right? We don't stop there. The 8 can break down. What times what is 8? 4 times 2, and the other one's the same. And are we done, or can those break down? 4 is 2 times 2, and 2 times 2. Okay, So now putting it all together, we have a negative. Let's put that negative in the front. What do we have now for the 64? 1, 2, 3, 4, 5, 6 2s. Those are all items that wouldn't break down any further primes, huh? They're the little building blocks of the 64. 3, 4, 5, 6. That's what a 64 is made out of. 6 2s multiplied together. That's his DNA. Doesn't matter how you break it down. If you just keep going, you'll get to that same point. Okay, now what's going to ship out? Yeah, it's a 3-for-1 deal. That's what this 3 in the hook tells you. Things are on sale today, 3 for 1. So 3 2s inside, sends 1 2 outside. The other 3 sends another 2. They multiply. It's going to be -4. 3 for 1, right? 3 2s in, sends 1 2 out. So 3 for 1 deal. 2 times 2 is 4, and the negative sign's there, so -4. Is that good? Questions? Square root of 272. Now notice there's nothing in the hook. You see how there's no number in the hook there? So then there really is a number. What number is understood to be in the hook if we don't write any number in there? 2. It's actually 2. I know most of our understood numbers are 1s, aren't they? It's actually 2. So when no number in the hook, right there, it is 2. Why? Because it's called a square root, right? Don't we call it a square root? And what does square mean? What do we call this? X2'd? X squared, right? So you know that, huh? Whenever we say square, we mean 2. What do we call this when we put a 3? Cubed, right? Cube is a 3-dimensional shape, so we use it for 3 in math. Square is a flat 2-dimensional shape, so we use it for 2 in math, don't we? So it makes sense that we call that thing a square root. When you say square, you're saying 2. So that thing's a 2 root. It's a 2 root. All right, anyway, doesn't matter. Same thing. Take your calculator. Take the 272 and break it down. 2 times, I don't know, whatever. Just use your calculator, break it all the way down. But when you ship out this time, it's not going to be a 3-for-1 deal. We don't have 3 in the hook. We have 2 in the hook. So it's a 2-for-1 deal.
Oh, okay, it's whatever.
Whatever you have 2 of, ship 1 out. 2 in, 1 out. 2 in, 1 out. Yeah, so break it all the way down and do. All right, I broke it all the way down like that. Two, 17. 2, 17. So 4 2s and a 17. That's a 17 doesn't break down, huh? It's prime. It's a big old prime number. So now, ship stuff out 2-for-1. So 2 2s in, 1 2 out. 2 2s in, 1 2 out. So what comes out? 2 times 2, 4. What's left inside? Now this time we have something left inside. Not everything got out of the root, huh? So what's left inside? The 17. So the answer is 4 root 17. The 4 on the outside, the 17 on the inside, because the 2 2s that came out multiplied to be 4. Does that make sense? How roots work? So that one was a 2-for-1 deal instead of a 3-for-1 deal because there was 2 in the hook. Now, see how in the end I didn't put any number in the hook? In that very last step, I didn't put anything in the hook. Because if you don't put anything in there, what's understood to be there? 2. So you don't need to write the 2. If you mean 2, you can just leave nothing in there. It means there's a 2. It's the only understood 2 I know of in math. There's lots of understood 1s, aren't there? But that's an understood 2. All that is over time, they use the 2 root so much more than the others. They ended up just saying, look, if I don't write anything in the hook, I mean a 2. Because that's just the most common one. All right, shall we keep moving? Questions on that one? All right, number 4. Third root of minus 27x to the 4th. Okay, So same kind of thing. That minus, let's just move him on out right now. Break down the 27. 3 times 9. 9 is 3 times 3. All right, so what does it become? We get the negative out there. We got the 3 in the hook. 3 3s. And now what do we do with x to the 4th? Well, just break it down. Right? X to the 4th means 4x's, doesn't it? Right? So we break down the 27 to 3 3s, break down the x to the 4th to 4x's, and then we do the same thing. We do the 3-for-1 ship out. Can you do that? It's a 3-for-1 deal on this one, right? Because of the 3 in the hook. Okay, so 3 3s inside, 1 3 outside, and they're gone. 3x's inside, 1x outside, and they're gone. So what do we got on the outside? Minus 3x. What's left on the inside? A single x. 3x cube root of x. Negative 3x cube root of x. Yeah. Okay, x to the 24th, y to the 12th. Now, what should we do on this one? Well, how about I write it out terribly, painfully. It's not that terrible, but I'll write out 24x's. I'm going to do it that way once. And then afterwards, you can notice the logic, so we don't have to always do it that way. Or you can just watch if you want. But I'm going to write 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Any idea why I'm doing them in groups of 4?
Yeah,
Because we're going to ship them out in groups of 4, aren't we? 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's 24 of them in Y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. So it's a 4th root of all that stuff. Right? So we're going to ship out 4-for-1. Right? That's what's in the hook. It's a 4-for-1 deal at Target. 4x is in, 1x out. They're gone. 4x is in, 1x out. They're gone. 4x is in, 1x out. They're gone. Etc. Every one of these groups of 4 sends out an x. How many x's come out? X to the 6th. So what would have been a quicker way?
Divide it.
Divide by 4, because you're saying how many times does 4 go in there, huh? And then what about y? 3 groups, y to the 3rd. Yeah, so the quick way, divide powers by the hook number, huh? Oh, the hook number is technically called the radicand. I never use the math words too much, but it's probably more helpful that I do. So in case you have another teacher later and he starts talking about the radicand, you'll be like, what's the radicand? You heard it here first. I just call it the hook number, but it's technically called the radicand. So the number in the hook there. Yeah, just divide the powers. The quick way would have just been to take 24 and divide by 4 and 12 and divide by 4. That would have got us right to the answers quick-like, right? And there's nothing left over in the root.
So that's the answer?
So that's the answer. No more root. Now, why is there no more root?
Nothing left.
Because there was nothing left in the root. That's right. The root completely vanished.
So there was like 3 left over under the root and like 3 x's and like 4 y's. You would just put x to the 6th, y to the 3rd, and then in the square root the x.
Yeah, whatever's left over would have to stay there left over. That's right.